Welcome to EC Elimu Learning Simplified and welcome to this lesson. In the previous lesson, we discussed the oil drop experiment, and what we realized is that the volume of the oil drop, which is spherical in shape, and its volume is obtained as 4 over 3 pi r cubed, will be the same as the volume of the patch which will be formed, which will be in cylindrical shape, and the volume can be obtained as pi r squared h, and in this case this h will represent the thickness of the oil molecule. So in this lesson we are going to discuss more questions concerning the oil drop experiment. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be comfortably solve questions on oil drop experiment. So the question reads, in an experiment to estimate the size of a molecule of olive oil, a drop of oil of volume 0.12 cubic centimeter was placed on a clean water surface. The oil spread on to form a patch of area 6.0 times 10 raised to power 6 square millimeter. Calculate the size or the thickness of the molecule. So in this case, we write down what we have. We have the volume of the drop, and this drop is spherical. Remember that it's spherical, and we have that volume as 0.12 square or cubic centimeter. Then we have the area of the patch, and this patch, remember, is cylindrical, and this area which we have the cross-sectional area in this case is 6.0 times 10 raised to power 6 square millimeter. Then now, since we know that this is spherical and this is cylindrical, then look at the units that we have. Area is in millimeter square and the volume is in centimeter cubed. Then in this case, we must change one to have common unit. If we change this area to be in square centimeter, then the relationship between a square centimeter and a square millimeter is that 1 square centimeter is equals to 100 millimeter squared. So in this case, if we have 6.0 times 10 raised to power 6 millimeter squared, then we can find it by cross multiplying, and we will get our cross-sectional area of that patch as 6.0 times 10 raised to 4 square centimeter, like that. However, I want you to note that the cylinder or the patch which is formed is in cylindrical shape, and this shape looks like this. So already we know the area. This area here is the one that we have been given here. Then now they want us to find the thickness, T, that is the height of this cylinder, and that will be the size of the oil molecule. So in this case, we write our formula. Volume of sphere or of the drop is the same as volume of cylinder, in this case the patch. So in this case, this sphere is the drop, and then this cylinder is the patch. So do we know the volume of the sphere? Yes, we can calculate it as 4 over 3 pi r cubed, which is the same as the area of a cylinder, which is pi, or the volume of a cylinder, which is pi r squared h. In this case, we are going to use T as our thickness of the molecule. But in this case, we are given the volume of this drop, which is 0.12 cubic centimeter, which is the same as pi r square. Pi r square is the area. This is the area. We are given the area as 6.0 times 10 raised to power 4 centimeter square times T. We are looking for this T, the thickness of that oil molecule. So in this case, for us to get T, we divide by 0.6.0 times 10 raised to power 4 square centimeter on both sides. 6.0 times 10 raised to power 4 square centimeter. And then if this one on the right hand side, they cancel out like that, then we will remain with T, which is the size of the molecule. Here on the left hand side, the square centimeter will go with square centimeter on top there, and then we will remain with centimeter. Then now our answer will remain as 0.12 centimeter divided by 6.0 times 10 raised to power 4, which is going to give us as T, or the size of the molecule, as 2.0 times 10 raised to power -6 centimeter. So that is the size of the molecule, that is T. This T is the one that we have obtained there. So the second question reads, estimate the size of an oil molecule if a drop of oil of volume 2.5 times 10 raised to power -6 meter cubed forms a patch of diameter 16 centimeter on the surface of water. So what you do here, you first write down what you have. You have the volume of the drop, which you should note that it is spherical in shape. It is spherical in shape, and that volume is 2.5 times 10 raised to power -6 cubic meter. Then the other thing that you are given is the diameter of the patch, and this patch is cylindrical in shape, and you have the diameter as 16 centimeter. Remember, this patch is in this shape. This is the patch that we are talking about. It's cylindrical, so we know the diameter as 16 centimeter. Now they are asking us to find the diameter of the size of the oil molecule. So we are going to find this size here, T. So in this case, what you need to know, first you must convert this unit. Since the volume is in cubic meter, then you have to convert this diameter into meter, and then in this case it's going to be 0.16 meter. And in this case now, then we can now write our formula. Volume of the patch, in this case spherical, is the same as volume of the drop, which is cylindrical. But in this case, we have the volume of the drop, which is in this case 2.5 times 10 raised to power -6 cube meter, which should be equals to volume of the patch. And this patch in this case is cylindrical, and therefore its volume can be calculated as pi r squared then times T, which is in this case the height or the size of the molecule. Then in this case, we can go on and say 2.5 times 10 raised to power -6 cubic meter is the same as 22/7 times the radius of this oil patch. The diameter is 16, therefore the radius will be 0.08 when we converted it to meter. If you divide 0.16 divided by 2, it will be 0.08, then squared times T. The T is the one that we are looking for. So in this case, we can proceed and say, in this case, it will be 2.5 times 10 raised to power -6 cubic meter, which is the same as the area. Now, if we solve this one, this area will be 0.02014 square meter times T, the T that we are looking for. Then now, if we want T, we will divide by 0.020114 square meter, divided by 0.00, not 00, but 0.20114 square meter. So in this case, on the right hand side, that one will go like that. Then we will remain with T, that is the thickness of the drop. T is equals to be 2.5 times 10 raised to power -6 cubic meter divided by 0.02014 square meter. This is the area of the patch. And then in this case, a square meter will go 1. Then on the upper part, we will remain with a meter. Then when we solve this one, it will give us 1, not 1, but 0.000 0, 1, 2, 4, 2, 9 meter. But the question was we should leave our answer in standard form, or if they want us to leave the answer in standard form, then we can write it as, remember in standard form you only leave one integer on the left hand side of that number. Then in this case it's going to be 1, 2, 3, 4. It's going to be 1.2429 times 10 raised to power. We moved on the right hand side 1, 2, 3, 4 raised to power 4 meter. Then that is how to solve that. So the third question reads, an oil drop of volume 0.004 cubic centimeter spread into a film of diameter 28 centimeter. Estimate the diameter of one molecule of the oil. Express your answer in standard form. So here, as usual, what we do, we write down what we have. In this case, we have the volume of the drop. This drop is spherical, and this volume is 0.004 cubic centimeter. Then the other thing that we have is the diameter of the patch. So we have the patch diameter of the patch. This patch is cylindrical and the diameter is 28 centimeter. And now they want us to estimate the size of the oil drop, and we express in standard form. So in this case, the first thing that we should look at is the units. In this case, we have the uniform units, centimeter and centimeter. Then now the first thing that we do, we write our equation. Volume of the drop is the same as volume of the patch. In this case, the drop is spherical and then the patch is cylindrical. So if we know that the patch is cylindrical and the drop is spherical, then the volume of the drop, or which is spherical, is 4/3 pi r cubed, which should be equal to the volume of the patch, which is in cylindrical, pi r squared h. In this case, h will represent the thickness of this molecule. But in this case, we don't have to use this volume formula for finding volume of a sphere, because already we are given the volume of the sphere. Then in this case, we could just write volume of the sphere, which is 0.004 cubic centimeter, is the same as, or will be equals to, pi r. Do we have the radius of this cylinder? Is yes, that is 28. That is the diameter. So the radius will be 14. In this case, it will be 28 divided by 2 squared times h, which will be our thickness. So in this case, we can write as 0.004 cubic centimeter is the same as 22/7 times 14 squared times h, where h is the thickness of this molecule. Then in this case, if we solve this one, it will be 0.004 square or cubic centimeter, which is equals to the area, this area here, this one here. If you solve it, it will give you 616 square centimeter times h. So in this case, if you need h now, you will divide by 616 square centimeter and divide the other side by 616 square centimeter. So in this case, on the right hand side, this one will go like that. Then we will remain with h, which is the thickness or the diameter of the molecule, is equals to centimeter square 1 centimeter square to centimeter cubed to remain a centimeter. So we remain with 0.004 centimeter divided by 616. And if you solve this, the size or the diameter of this oil molecule will be 6 in standard form. It will be 6.5 or 0.4, 6.4, sorry, it will be 6.4935 times 10 raised to power 6 centimeter. So that will be the thickness of the oil molecule in standard form. So the last question for today's lesson, the question reads, in an experiment to estimate the diameter of an oil molecule, an oil drop of diameter 0.05 centimeters spread over a circular patch of diameter 20 centimeter. Then determine 1. the volume of the oil drop, 2. the area of the patch covered by the oil, then 3. the diameter of the patch covered by the oil, and then finally state the assumptions made in the above experiment, and then number 5, state 2 possible sources of error in the experiment. So in this case, we're going to begin with the first one, that is number 1. But before we begin with number 1, let's write down what we have. So here we have the diameter of the drop, which is the same as 0.05 centimeter. Then we have the diameter of the patch. Diameter of the patch, in this case, it is 20 centimeter. Then now, if we start with question 1, can we calculate the volume of the oil drop? The drop in this case, remember the drop is spherical. If the drop is spherical, then it means if we want the volume is 4/3 times 22/7 times radius cubed. And in this case, if we substitute, we have the radius, we have the diameter as 0.05. Therefore, the radius of that one will be 0.00. So the radius here is 0.025. In that case, that is the radius. When you divide 0.05 divided by 2, it will give you 0.025 centimeter. So in this case, if we want to calculate that the volume of the drop, then it's going to be 4/3 times 22/7 times 0.025 then cubed, and this one is going to give us the volume of the drop, as, if you solve that, it will give you 6.5476 times 10 raised to power -5 centimeter cubed. Then now the second question, it reads, find the area of the patch covered by the oil. Now when this oil drop of this volume fell on top of water, it formed a patch, and this patch we said is cylindrical in shape. Now if we draw our sketch of a cylinder here, and the diameter of this cylinder they have given us as 20 centimeter. So in this case, the volume of a cylinder, they want us to calculate the area, but not the volume. So in this case, if they want the area, the cross-sectional area of a cylinder, the cross-sectional area of a cylinder is pi r squared. So in this case, pi r squared, we have the diameter as 20, therefore r in this case is 10 centimeter. Then now if they want the area, it's going to be 22/7 times 10 squared, which if you solve, it will give you 314.28 square centimeter. I want to minimize the space because we have other questions here. Then the third question here, they are asking Calculate the diameter of the patch covered by the oil. The diameter of the patch, if you need the diameter of the patch, is this height here. We are looking for this height. Let's call it D. So in this case, if you need the diameter, then you will equate the two volumes. Volume of the drop is equals to the volume of the patch. Now the formula for finding volume of the drop is 4/3 pi r cubed, which will be the same as volume of the sphere or of the cylinder in this case, which is pi r squared. H in this case D is the diameter of the drop. So in this case, the pi r squared, pi r 4/3 pi r cubed, this is the volume which we have calculated up here. So here we'll just place it here. It is 6.5476 times 10 raised to power -5 cubic centimeter is equals to area. Pi r squared is the area we have calculated up here, so which is 314.28 square centimeter, times the diameter of the patch, which is D. So in this case, for us to get D, then you divide by 314.28 square centimeter divided by 314.28 square centimeters. And then on the left hand side, this one will go. We will remain with D is equals to, here on the left hand side, we will have centimeter square going with 1 centimeter. Here we will remain with centimeter. And then now, if you solve this, 6.5476 times 10 raised to power 5 divided by 314.28, it is going to give you 2.0833 times 10 raised to power -7 centimeter. So this will be the thickness or the diameter of the oil drop or the oil patch, all of the diameter of the molecule. Now the fourth question, state any assumption. The first assumption that we state here is that the patch which is formed is a perfect circle, and then the drop was a perfect sphere. Those are the assumptions that we discussed in the previous lesson. Then state two possible sources of error. Sources of error, I told you, they are associated with the measurement. What have they measured here? They measured the diameter of this drop. So there is the first source of error is an error which is associated with the measurement of the diameter of the drop. The second source of error is the measurement of the diameter of the patch. When they are measuring this diameter of the patch, they might make an error. So those are the two sources of error. So that marks the end of our lesson today and the end of our topic measurement 2. In the next lesson, we will discuss turning effect of a force as our third topic in Form 2.